Hey guys, Mr. Myesis here, and hope you're staying safe. If you watch this video and it's not 2020, then you might remember that we had a pandemic outbreak. Some of us are locked in our houses, so that's what's happening right now. But I want to get some videos out here for your help, and hopefully you find this video helpful. Now, what I'm going to do on this video today is I'm going to show you how to do the normal distribution, so some problems with the normal distribution using a TI-84. So normally on my videos you see I use a TI-Inspire. This time I'm going to do it on a TI-84 because I know some people would like to know how to do it on there. If you want a TI-Inspire, go take a look at some other videos. So let's take a look at some normal distribution problems. Let's see if I can minimize my screen here. All right, so here I have a new power ratings for supervillains, and suppose the power rating can be described by a normal model with a mean power rating of 43 and a standard deviation 12.5. Notice here I've already identified the mean, so mu is 43, and the standard deviation sigma is 12.5. I've drawn my normal distribution, and I'm going to get back to where that shading is in just a second, but I've drawn my normal distribution based on the empirical, we call the empirical rule. So that's the 68%, 95%, 99.7% rule, which means that 68% of the population is between one standard deviation from the mean and then out 2 and 3 standard deviations. So we're going to do here, make sure you can label that, right? You're going to need to be able to label that normal distribution there. You always want to have some context as well. Power rating for supervillains. Bam, it's there. And then down rating. So let's take a look at letter B. I was going to say number B. Numbers, letters. Nobody knows in these times. So what percent of villains have a power rating that's less than 30.5? Generally speaking, even though we can do a lot of this stuff in the calculator, we want to show some work. We want to make sure that we're understanding how to use that normal distribution. So for my class anyway, and this is true for most classes, you're going to want to show at least your calculation of your z-score. So make sure you're showing that calculation for z-score. So here's the calculation, and excuse me if I get up too close to this guy here. So the z-score is x minus mu divided by sigma. So x is whatever value that I'm looking for that's either going to be less than, greater than, in between, whatever those value is, that's going to be my x. So in this case, my x is 30.5. Okay, so by the way, it says less than, that's why I have it shaded underneath, because I want all these values. I want the probability that it's less than that, or the percent less than that. So I'm going to have 30.5 minus mu, which was, we just had it, 43, divided by 12.5. And I'm trying to write a little bit nice here, but it's hard to write on this pad here when it's up like that. So now we're going to do some calculation. I'm going to zoom in on just so this work here so we can see that. All right, so now I have my calculator here. Bam. And I'm just going to do this calculation really quickly here. 30.5. So with this, I'm going to want to do parentheses. 30.5 minus 43. Close the parentheses, divided by 12.5. I should get 1. Negative 1. Negative 1 is my z-score. All right, so I'm going to go back here, and I'm going to put that's negative 1. So really what I'm asking is for the probability of everything that is less than negative 1, because we know that because it's 1 standard deviation below the mean, so that's what z-score is. All right, so now I'm going to find this probability. Now, in order to find this probability, I can use my z-table. And if you want to know how to use a z-table, I have a video on using a z-table. You can use a z-table. You can use a TI-Inspire. You can do that too. But for this video, like I said, we're using a TI-83 or 84. So we're going to take a look here. And the function that you want to use is called normal CDF. In order to find this function, you're going to go to second vars, which is distributions. Okay, that's my probability distributions. Okay, it's going to take you to all these probability distributions. I would like to use a normal distribution, so normal CDF. Enter. And now if you have updated software, this should be how it looks. If you don't have updated software, I recommend you going online and just go to TI, Texas Instruments, and there's updated software for your TI-83 or TI-84, and then you can get the update so it looks like this. It's a little bit easier when it looks like this. So my lower bound is going to be my lower z-score. That's way out over here. All right, so way out over here, way out here, what's my lower z-score? So this is -1, -2, -3. These are z-scores. Way out here, just pick a negative number that's really, really, really large, or really small, I guess, the way you're thinking about it. So the default here is already to give you a very, very large negative, -1 times 10 to the 99th. That's a pretty big negative number. But if you want to, you can, I just normally say put -9999. Like that's big enough. A couple, 4 nines, right? Okay, hit down. Now your upper limit is this time it's going to be -1. So think about this way. My lower is over here. It's way over here, right? And my upper is going to be the value that I want because I want everything less than that. So if everything's less than that, my upper is going to be -1. You'll see an example in just a second where my upper and lower, they kind of switch because I'm looking at greater than. If I'm using z-scores, I'm going to keep my mu at 0 because that's my mean for z-scores. The mean for z-scores is 0. And my mean for standard deviation is 1 because I'm going 1 standard deviation above and below, and that's for z-scores. I'll show you right now that you can do this without a z-score, but I wanted to show you z-scores first. All right, and then so we're just going to keep those the same, and we're going to hit paste. Hit enter. And then it gives you the paste there. You're not done yet. You have to enter one more time. And we get our answer 0.1587. 0.1587. And so what I'd like to do is do that. I like my students to put 4 decimal places there. So 0.1587. Now, if you wanted to do this not using z-scores, so we could go directly from this information here, given what we have here and here, our mean and our standard deviation. So this is what it looks like. So remember I said that when you did this, so we go again, second vars, normal CDF. Oh, come on, 2. Okay, our lower we're going to keep as -99999. Okay, it's going to be pretty lower. But our upper now is going to be, we're going to use the values that we already have. So this value is 30.5. All right, so 30.5. And now my mean, I'm using the mean that's given, which is 43. And my sigma, 12.5. And then I'll go ahead and paste that. Hit enter again. And we get the same answer. So remember, though, that the important thing here is that when you're using the TI-84, you are aware that the mean and the standard deviation that you're using are either the one, if there's z-scores, you're using 0 and 1. If you're using the values that they gave you, the mean and standard deviation, then you have to, you're not using z-scores, you got to use what's given to you, okay? So be careful. Now, again, if you're one of my students, I want to see your calculation for z. So however you're doing it in your calculator to get the answer is up to you, but I need to see what you're doing for z, all right? And I would say most teachers out there and professors would want the same thing. Let's take a look at another example, and then I'll probably cut this into a couple pieces here, given that we are at 8 minutes and 47 seconds. All right, so let's do, what I'll do is I'll do C here, and then I'll stick the percentile ones on another video, okay? Okay, so what percent of villains will have power rating between 41 and 65? So since we're talking about in between, you know, we're really looking at, let's see, 41 is going to be, 41 is down here somewhere. All right, that's like right here, 41. And then 65 is going to be somewhere over here. So we're looking at the area shaded in between. So we're going to need 2 z-scores. Z1 is going to be 41 minus 43 over 12.5. And Z2 is going to be 65 minus 43 over 12.5. And we're going to find the z-score for each of those. Okay, so let's go ahead and do that. All right, so what we got here is -0.16, 1.76, and so what we're looking for is the probability that the z is going to be between 1.76 and negative 0.16. All right, so let's go ahead and find that in our calculator. And again, we're going to do this using our TI-84. So we're going to do second vars, so that's distributions, normal CDF again. This time our lower is going to be, so since we're doing the, let me see if I can come back to this. Since we are doing in between, all right, so our lower is actually going to be this value right here, and then our upper is going to be this value right here. So this is our lower, and this is our upper. Now, if we were shading above, because I'm not going to get to that on this video here, but if we were shading above like this, then this value, whatever our z would, that was going to be our lower, and then our upper is way out here, which is probably going to be positive 99999. Okay, so that's how that changes from the first one that we did. All right, so let's go and enter this in. We've got a lower and an upper for this. Our lower is negative 0.16. Hit down. Our upper is 1.76. And then we want to change that mu. It still has it from what we did before, so we're going to see 0 and 1. Why is it 0 and 1? That's right, because it is a z-score. Way to play along. You're participating with a video. Okay, 0.5244. So 0.5244. Let me just check my work. That's correct. All right, so there you go. There are a couple of examples of using the TI-84 for a normal distribution problem on another video. So I'll probably pop this video up here soon. I'll be doing some percentiles, so showing you how to do a percentile, which is the reverse, and then doing an IQR. So that'll use, instead of using normal CDF, I'm going to use what's called inverse norm. So I'll catch you on the next video, guys. It should be up soon. Later. Oh, stay safe. Subscribe if you can. Thanks a lot, guys.